All right. So remember,
Inverse function.
from
You get that?
year 9,
Equals this.
A is a base, B is the power or the exponent, or
2x,
yeah, it's power or the exponent.
which is x.
All right. So a logarithm is an inverse operation that expresses a relationship between a base and its exponent. Given that logarithms are the inverse of exponentials, we should be able to interchange in their form. All right. We use logarithms to undo the exponentials
He's too good.
and solve for unknown indices.
Yep.
So if we have a general exponential a x to the power of
That's what
b,
you do when you're number 1.
then we can rewrite this into the logarithmic form. Log a, the base of b, is actually x. All right, where a is the base and b is the resulting value of the exponential, and x is the index or exponential. All right, we call this the exponential form. We call that the logarithmic form. So make sure that you know the difference between the exponential form and the logarithmic form.
Yes.
We are used to exponential form. We have done a lot of it,
What happens if you divide logs?
but we haven't done any
I think
logarithmic form yet.
Oh yeah.
All right. So just quickly, generalization. If you want to write anything down, this is the most important one at this stage. The inverse algebraic relationship that exists between the exponential and logarithm is established as, the question mark shouldn't be there, this and that. Exponential form is ax to the power of b, and then the logarithmic form, log of a, b equals to x. All right. Now, a can be any number. Later, I'm going to show you what is the domain for a and b. All right. I want you to think about a in this case. It could be log 10, log 2, log 3, or log whatever.
Log 0.
No, it can't be log 0.
So you said it could be any number.
So, let's have a look at this. Can a be negative?
Yes.
I know that a to the power of x is b, and if we have a equals to negative 2, what happened? Minus 4, 6, and minus 8.
Yep.
Yeah? Square? So
So
think
A
about that. Can a be negative
Yes.
from there?
Yes.
Can b be negative?
Yes, but not 0.
Is that a situation where a to the power of anything
Oh no, B.
is less than 0? Less than or equal to 0? I want you to think.
No,
Can B
can't do
be
that.
negative?
Can log b be negative?
No. Oh.
Log b, can it be negative?
Oh, B
Can that be
can't-
negative
B
x?
can't be negative, but
B
log
can't
B
be
can be
negative.
negative.
No, B can be negative.
Which one can be negative?
Log B. Log B.
Which one can be negative?
Log
B.
B.
No.
Log B. Log B. Log B.
I'm
Look at the
tripping.
thing again and
Well, if A can be negative, then B can. B can.
Yeah, it can be negative.
B can't be negative.
alright. Now,
But if I have negative 2
Log
as
AB
A,
can be negative.
what I want you
A
to
is
do is
negative, then
think
if I do
about,
negative 2 to the power of 1,
use
B
this.
can be negative.
Log A, B, can A be negative? Can B be negative? And then log AB, can it be negative?
Log AB cannot be negative.
No, it can. It can be negative.
That means they can all be negative.
No.
Well, how can B not be negative?
Alright,
B can be negative.
let's start off with the properties
it
of A.
It can.
Alright,
Because if you have a negative 2
If
to
it's
the power
base,
Let's think
negative
about-
2. If it's a negative
why
base.
can't A be negative? Alright, I've already given that to you, given away. So, if we think about negative 2 squared equals to 4, and negative 3 squared equals to minus 8.
Oh, log
Now,
continuous.
if you observe the
It's a
graph
function, remember?
such,
Log is a
such as
function.
minus 2 to the power of x,
Yeah.
all to the power of x,
So it's-
it does not form nice continuous graph like 2 to the power of x. Alright? Let me prove it to you. Let's use the class pad. I'll show you what to do.
Yeah, I'll definitely.
No.
Where is it? Where's my
My
Desmos?
class pad is here. Alright, let me show you.
So I'm going to just use Desmos.
Or just look at it.
If I go to graph and table, now watch when I plot 2 to the power of x. And let's do that first. Plot that. You are all familiar with this, right? And there's an asymptote. It doesn't go past 0. Alright, now, what if I have negative 2 all to the power of x. See, it goes up and down, up and down, up and down, up and down. Look at the red point. I'm going to enlarge it a bit more if I could. No, I can't.
Oh, yeah, that's more than two.
Alright, so if I draw it again, you can see that it's going up and down, up and down. It's not smooth.
This one's a bomb.
Yeah.
There is no connection between that. There's nothing in between. You can't have minus 2 to the power of 0.5.
Wait,
Yeah.
so logarithms have to be continuous. Okay.
Alright? So, therefore, in this situation, you can see that, let's go back
It'd
to
still be a
PowerPoint.
function though, right?
We can't have a negative base.
Technically, it's positive.
Alright?
but
So
it's
the
not.
value varies depending whether you have even or odd exponent. So in between, you can't have, for the base of minus 2, you can't have minus 2 to the power of 0.5
B cannot be negative.
because it's a complex number. We are not dealing with complex number at the moment.
Oh, if A
Alright?
can be negative,
So
then
therefore,
B can be negative.
one of the properties,
Log A, B.
logarithms do not use negative bases at all. We don't have negative bases for logarithms. Yes, A can be negative when you're looking at exponential, but coming to log, no. No negative bases. Now, why can't it be negative?
Because A is positive. Okay.
Yes.
A is positive.
Because A is positive, since we are only dealing with positive bases, regardless of any power, 0, 1, fractional, negative, or whatever, the value of the result is always positive. So therefore, the value of B is always positive. So A cannot be negative, B cannot be negative. Alright? Now, last but not the least.
Not
I'm not quite yet, not the least yet. Why can X be negative? Because
the, it's a
if you have a
fraction.
situation like 2 to the power of minus 3 is 1 over 8.
If B is
So
less than 1,
So, what would that be?
X always
Not
X will be
necessarily.
minus 3.
What about minus
Log
the
A,
negative one?
log base of log 2 of 1 over 8 is X. Alright?
Yeah, so,
So therefore, X can be
except
negative.
for 1, right?
So the X here, remember,
So-
X is the power,
Oh, no, what about
the
zero
And
point
if,
exponent.
five?
yeah, but
Alright.
if A is less than 1.
So
That's a
therefore,
lot of
A and B
exceptions,
cannot be negative, but
Oh, look. That's what I said.
X can be negative if B is between 0 and 1. Alright? So it has to be between 0
So
and
what
1.
if, what if A is 1?
But what if it was log base 0.5 and then it was like 2?
Yes, then you could. I'll show you an example.
Stop being a
Yes,
stinker. Stop trying to
you could
find
have that
exceptions, bro.
situation. Alright? Now,
Yeah, it is stinker.
a logarithm with base 1 and 0 is undefined. So if A equals 1, 1 to the power of x for any power of x, whether it's positive, negative, or even 0, will always be 1. Therefore, it is useless to consider cases of log 1, 5, or log 130 because this is not possible.
Yeah.
Alright? And then similarly for a to the power of 0. 0 to the power of x for any positive power of x will be equal to 0. For any negative power of x will be undefined. And you cannot have x to the power of 0 as well. So therefore we don't have a log of base 1 and 0. Now,
So sad.
so can you express, for example, the following exponential statement in logarithmic form? How are you going to change this to something like this? Change from ax, a to the power of x equals to b, to log a, b equals to x. So now you know that the 6 is a, the base. Alright, that is your b, and therefore, what is x? That is your power. Alright? So, just changing it, log base 6 of 36 equals to 2. Now, with the second one, you should be able to solve for x. Correct? Because it's log, excuse me, of base 5, 135 equals to x. And you know 125 is 5 to the power of 3. Yeah? Agree? Since 125 is 5 to the power of 3, therefore x would be 3. can you try the rest, please? Now, the next one, I'm a little bit cheeky. You could actually change the right hand side to the left hand side. Alright? So that you know these have the power of minus 1.
Yeah. 5 to the 10.
Negative log
Alright.
pH.
Next one. 5 to the power of 2 root 3. 2/3 is the same as that. Keep going. So you do have the situation, this is just trying for you to learn how to change from the exponential function to the logarithmic form, that's all.
Sir.
Yep.
Is it? Is it just one?
Which one?
On
Which
So
one?
it's 1 on 10. 1 on 10 is 0.1.
0.1.
Oh,
10 to the power of minus 1 is 0.1.
oh,
Correct?
yeah.
Yeah?
What's the last
10 to the power of minus 1 is 0.1. So log of log base 10 of 0.1 is minus 1.
10 to the negative 1. The same as 1 of it. Which is
Alright,
Lit, crazy.
let's move on to the next
I
one.
like 10 to the
Example 2, can you express the following in terms of exponential form?
Yes.
So, basically you know that that is a base. That to the power of 6 will give you
1,000,000.
so pretty much straightforward.
Yeah.
10 to the power of 6 is 1 million. And then you should be able to solve for x in this case. 4 to the power of something is 64. What is it?
3.
3. So you should be able to solve
Oh,
for
you
x.
see how
in this
quick
one.
I was there, bro?
Bro, that is not.
And the next one is going to be a...
Brother, you gotta put the.
Now challenge me
Well
to
done,
get a
man.
different
The
Right.
combination.
next one is going to be a negative number. Why? Because it's 1 over 2.
Well done, man. My guy. You
Alright.
got through his beat.
Now here,
Chat on the floor. Move that cornflakes. Rice Krispies. What the hell?
you know that the base is 81.
Those.
81 to the power of half or square root of 81 is 9.
The power of 3 is 4.
And
Oh, wait,
then
4? Yeah,
4 to the power of 3 is 64.
So how is that negative in total?
Hmm?
How does that make it negative in total?
So,
You know?
it's not negative, sorry, it's my fault. It's not negative, it's just half. It's square root of.
6 factorial.
Yeah.
7 factorial. It's 10 factorial.
Sorry, it's my fault.
You're joking with me, mate.
I'm not.
It's not negative. I'm not thinking
Mate,
straight.
You do it, mate.
I've done it, mate.
Alright. Now, so in the course that we are doing, alright, given that our number system is decimal,
8 times 9.
the common logarithmic base to consider is base 10.
No, it's not.
So as a result for this course only, if we say log v is log 10b, alright, be very, very careful. There are other convention that's used. I was talking to Dr. Moore about it, and he was telling me that log in computer science, log b means log 2, base of 2. Because in computer science it's binary.
Yeah,
You're looking at binary. So you got to be very careful where you are. What we're doing now is log 10, alright? And when I was learning, this is what we use, LG, as log 10. But it's not, that convention is not here. It's not used here. So the convention for this course, alright? Generally, you see log something, that means log 10, base of 10. All the others, you have to say log 2, log 3, or log 4, log 5, alright? So you must remember that. Later, we'll learn natural log, which is e to the power of something, and we'll use ln, that's a natural log.
Times 3.
We'll do that in about a week's
Okay,
time.
mate. Okay, mate. Yeah.
Now,
Then to get
can you
8.
evaluate the following?
To get
So,
10, you do that.
you know that this is base of 10. 1000 is 10 to the power of 3, correct? Straight away you can do that, or if you like,
16.
you can write down log 10 to the power of 3.
Sorry.
Alright?
That's okay.
So therefore you got 3. Now, this is the example, log half.
2, 4, 6, 8. 2, 4, 8.
Alright,
16,
so log
32,
2 to the power of
46.
4. Now, if you're not sure, if you can't write down straight away, write down this. 2 to the power of 4, log 2 of 2 to the power of 4. And straight away you know that this will be what you're looking for. The exponent.
It's 6, sir.
Alright?
It's 6. Sir.
6, sorry, what did I say? 4. I have no idea. I was half asleep when I was doing that. It's 6, my fault. I know why. I was thinking about something else. Alright, it's 6. It's my fault. I'll change that. 6. Now, what about 3125? What is square root of 3125?
Did square it on, yeah.
5 to the power of
2, 4,
5.
126.
Now I cheated with this one. I actually did use a calculator to find the square root of 3125. It's log 5 of 25. Okay, 3125 is 25 times square root of 5. Alright, I cheated with this one. I wrote that one out first.
Sir, you
And
can't
then
cheat.
I rewrote this and 5 to the power of 2 and 5.5.
Oh, I got it. I got it. I guessed it.
You just guess it, bro.
And you get it, and it's 2 plus half, which is 5 over 2.
I guessed it. Let's go.
You guessed it?
Yeah.
No.
Alright, try the next one.
No
Next 3.
way.
Write it in terms of the base. So 1 over 49 is 7 to the power of,
Negative 2.
sorry?
Negative 2.
Negative 2.
So it's equal to negative 2. Walking on a
Which is minus 2. Now what about half to the power of what will give you 32?
Negative 5.
Negative 5.
Yeah. So here you need to be able to work that out.
The louder you say it, the more people like go. Oh my
And
God.
then the last one is
The
pretty
more
much
people that go. Oh my God.
3 to the power of 1/3. And therefore, that's it, minus 1/3. So the aim of the lesson today is for you to be able to change in between the exponential form and the logarithmic form, and then be able to evaluate this. Alright? That's all I want to do today as an introduction. Sadler, exercise 1A, I think.
They will be done.